I'm Pete Ward. I ran or ran originally Heritage House as a building contracting company, and then got involved in surveying, and we now run Heritage House Survey, which is a national survey company that focuses on historic buildings. I think the strength that our group has got is that nearly all of the people involved have actually pulled buildings apart like this and rebuilt them. So when we survey the buildings, we actually understand the fabric that we're looking at. So it does make a big difference. We find that in order to really help a client, you have to have taken buildings apart. You have to understand what it costs to pull a piece of timber out and replace it or repair it. You have to understand the materials the building's put together with. Are these breathable materials, or are they modern materials that are causing problems? And most surveyors just don't understand that. So we come at the survey from a much more practical viewpoint. It's not theory, it's this is going to work or if this is not going to work. And we now understand why the building has problems, because we've looked at the evolution of the building over time, what interventions have been made, and how those interventions have affected the historic fabric, and what materials have been used and why they're causing problems. My mantra is always go looking for the moisture. The main thing that causes a building to deteriorate is water, it's moisture. So if you understand where that moisture comes from, how it moves about and where it goes to, that's going to tell you a lot about what's happened to the building and why it's in the state that it's in. And more importantly for the client, I have to be able to turn around and say, right, if you're going to buy this place, you're going to be spending X, Y, and Z. And then on top of that, the next little bit is this building legal? That's where we run up against a brick wall on a frequent basis. People just seem to think that a listed building is frozen in time. The legalities of the building, they don't really understand those legalities. They think quite often that just the outside's been listed. We have to explain to people what the legality is. Then we have to go back into the planning and look at the planning side of it. This is a very good example of a building that I walked up to it, looked at it and thought, hang on a minute, this has got to be illegal. And the more we dug into it, the more we found that years of architects and builders had continued to work on the building, they'd done things, but actually there was no conservation supervision. They got permissions for bits and pieces, but there were all sorts of outstanding issues that had never been sorted out. Big sections of the building had been worked on completely illegally, and it was quite obvious that there was no consent for any of it. My problem then was, how do I advise the client? What is he going to do in terms of purchasing the place? What allowance has he got to make? Are we going to have to pull the building apart and rebuild it? Can we put it back to what it should have been? What was that going to cost? So it's a big issue. A lot of responsibility on the surveyor. We have a very litigious society that wants to blame the surveyor for not pointing something out. You do surveys on buildings like this, and then you sit back, you write a report, you gather the information that you've got, and then you sleep on it, and you sleep on it, and you discuss it, and you look at it, and then quite often you will sit down with the client. And in this case, I sat down with the client and said, you really need to think hard about this. I like to think that he went into this prepared. I think he knew it was going to be a battle, but he could see the potential. In the end, in this case, we had a very substantial amount of money that was taken off the purchase price. I think we got quite a reduction in the price. We knew we were going to hit problems, and the vendor was understood that and knew that. So we got a very good price. Whether that will cover the cost of the work being done, probably not. But at the end of the day, the client went in with his eyes very wide open. That essentially was the survey job. Assessing the fabric was secondary. We came back several times to look at the fabric and to get a better understanding of the nature of the problems with the building. Again, it brings out some of the issues involved in surveying historic buildings, because I need to be able to walk up to a timber frame and poke it and prod it and hammer it and feel the timber and understand what's holding, what joints are tight, what's not tight. And of course, when you've got a vendor who's sitting in the house and you tap a bit of timber and they jump up and down, they don't like it. So it's actually really difficult to do a proper survey, an invasive survey, as it were. People cover things up, and you're moving little bits of timber and you're looking behind it and digging compost out from behind a bit of timber and going, oh, that sill beam's not very happy. You find you're walking around trying to work behind something, trying to cover something up. Very difficult sometimes with these to really get a full understanding of the building. And it's okay if you've got a professional. If somebody bought the building and you're doing a survey to inform a restoration project, but when you're pre-purchase and you are trying to actually work with a client and make them understand that there are likely to be an awful lot of things that you cannot evaluate until they own it. Where do you draw a line in the sand, as it were, and say, I think you're going to spend 200, 300, a million, but you know what, I can't tell you. I can't actually put a cap on that figure. You're going to have to understand that we think it'll cost this, but we don't really know until we open it up. That actually, with this place, was a very good example. I put a figure on it, the client was pretty surprised, and I think we're going to exceed that by a fair way. I think this place is actually in worse condition than even I thought, but he's a good client, and he's got an understanding of old buildings which a lot of clients don't have, and he's gone to the trouble to learn about the building, the skills, the materials. Some clients don't do that. They just want to live in a nice house and they want it done. It's been a very long journey so far, and it's tested a lot of people's skills. I look at surveys as something that you wear dirty jeans and a t-shirt and a parka. You have to expect to get dirty. I think I see a lot of surveyors turn up on site and they've got a shirt and tie and so on and shiny shoes, and I'm sorry, but you can't look at an old building like that. You've got to be prepared to get very dirty and not be afraid of cobwebs and spiders. We will go into every little hole you can find. You have to. If you can't get into something, then you have to develop techniques for assessing if there's a hidden area. Is that area likely to be suffering from moisture? At the end of the day, the biggest problem with any building is going to be moisture. So we, for instance, have thermohygrometers that have a long probe on them, and the probe is only 4 millimeters diameter. So you can poke that probe into a hole, and that probe will tell you the moisture content of the air in that cavity. So you get a much better feel for what's going on. The other thing that we do, we're very, very hot on taking moisture measurements throughout the building. When you get there, you'll turn the thermohygrometer on and you will measure the moisture in each room. And we look not at relative humidity, we look at the absolute grams per cubic metre. So we want to know what is the physical moisture content of the air in each room, and how does that vary going up through the building. And generally speaking, you'll see a slight increase as you go up through the building. Moisture always rises. Quite often, when you look at those results, it will point you in the direction of an area of the building, and you might think, oh, it's only very slightly high, but you then look at that area a bit more and you may find that, for instance, there is an inaccessible subfloor, and when you go really looking, you see the ground level's risen a bit, the ventilation is not as good as it should be, and so we've got problems with the subfloor in that area. We use thermal imaging. Thermal imaging is excellent for picking up variations in heat. When moisture is evaporating, then obviously that surface will be cooler. Quite often you'll see very subtle changes in the building fabric, in the temperatures, because of moisture. Thermal imaging is also brilliant for finding hidden timbers. I did one particular place down near Southampton. It was brick built, everything was brick. Got the imaging camera on the walls and found that there was actually a beautiful timber frame behind it all, totally hidden. Nobody knew that it was originally a timber frame, and the frame was all still there, but hidden by the blockwork inside, and no one knew it was there. Very often you will find that there are parts of the building that have just been blocked off. Getting into those is difficult. You do sometimes have to tell clients, look, there is a section of this building we just can't get to, and we have to allow for that. One of the things you'll see in these reports, as you pointed out, is get a specialist report. That unfortunately is part of the shortcomings of the survey industry in this country, in that understanding of moisture has not been taught in universities. So we have a massive problem. Very few surveyors understand moisture. They all walk around with a damp meter, doesn't even measure damp, and trying to educate people that moisture and the way that moisture reacts with timber and understanding that moisture is it's actually very simple. They're afraid of it because it's not taught, and they're afraid of it because nobody can explain it in a very sweet and simple manner. And hopefully that's something that I'm going to be doing with people shortly. I mean, to summarise timber problems, you do not need to treat timber, and never have needed to treat timber. I don't know anyone in the industry really that understands timber that would even dream of putting chemicals on it. Our attitude is, if the timber is dry, it's not going to suffer from problems. If you see beetle activity, for instance, that beetle activity is not going to be ongoing if you dry the timber out. If you see rot or fungus, again, dry the timber and that rot and fungus will gradually die out. So that's not something we panic about when we see it in surveys. The biggest thing that we look for is lifestyle. We walk into a building and we say, how are people living in this house? Are they producing a lot of moisture? How is the house ventilated? Is moisture being moved out of the house when it's produced? How many people are living in it? People don't understand that the average building, the average family is producing probably 2 gallons of water a day just through living. Now, if I were to stand in the middle of their kitchen and pour even a gallon of water on the floor, they'd be very unhappy. But they don't understand that that moisture is creating what I call moisture stress. And that moisture stress is then diffusing into the building fabric. And it's by removing the moisture stress from the building fabric that it dries out and ceases to be a problem. That's really how we approach surveys, and it does annoy me when I see other surveys recommending go and get a timber and damp survey. And I think it is a product of very bad education. You can't really blame a lot of the surveyors out there because they don't know anything better. I think it's up to us to get to those surveyors and show them and educate them that actually this stuff is not rocket science. It's very easy to understand moisture if you're given the opportunity to learn about it. So that's my take on it. Yeah, one of the first things that we do in any survey is look at drainage, and I think if I had to put a percentage on, I'd say something like 50% of problems with buildings. I always talk about tin hat and welly boots. If you get your welly boots right and you've got dry feet, then the house is going to be a happy house. The problem with many houses is that people forget about drainage. You've got downpipes and they sort of go into the ground, and so long as they go into the ground, that's fine. You can't see water, but actually that water has to go somewhere, and most drainage systems are old, broken, cracked, and this is a very good example. Obviously we've taken bits and pieces apart now, but down at the bottom here you can see how the downpipe is going into a gully. It's not even really aligned with the gully, and what had been happening, water had been splashing around here, and it's found its way all around the edge and soaked everything, and the result was that the cellar was very wet. And it wasn't until we actually started work here that we found that this was all blocked. As Christian says, the soakaways are in clay. They've stopped working, so we've got rainwater coming down here, partly going into a gully, and then it's going into a blocked up soakaway. And the result of that was this massive sort of build-up of moisture all along here, and then in the cellar were just constantly wet cellar walls and salts starting to come out of the cellar walls. And those salts are there because the water is literally just starting to dissolve the lime and starting to dissolve the binders in the sandstone, and everything was just falling apart. A simple solution: sort the drainage.
One thing that we see all too often in historic buildings is the incorrect use of materials or incompatible materials. And at Orleton Manor, there's a lot of cement filling of timbers and mastic. And as you can see here, it's been built up over time, and the cement has caused moisture to be trapped. And then as the moisture is trapped, it causes rot behind. Generally, these bits of cement fill out, people fill them back up again, and the hole just gets bigger and bigger.
And you can see an example of that here, where there's a mortise in here in the timber with a tenon sticking up into the mortise. The cement's been removed from this joint, and you can just see how moisture's built up behind the cement and rotted it away. Another issue we've had here at Orleton, and you can't see a lot of it now, but there's a little bit there, for instance, is paint. And we see people painting timber, which has almost the same effect as putting cement on it. Paint traps moisture. When timber like this is covered with paint, it softens behind the paint. This is one of the best examples I've seen for a while now of very heavy coats of bitumen. Why does that timber get wet? Where does the moisture come from that gets trapped behind the paint? And I've heard this asked frequently. You've got to imagine that the air that's around us at the moment, we're not seeing water. This is water in the air as a gas. Water in the air as a gas is able to diffuse through these materials. So if the main source of water in a building is people living in it, moisture is diffusing through the building fabric, and it's actually going from inside out, not from outside in. If you've got plastic paint and bitumen on the outside of a piece of timber, that moisture is diffusing through the timber very happily until it hits the back of the paint or the tar, and then it sits there, it can't get out. And so that's what I talk about, moisture entrapment, moisture from inside. It's the same sort of thing as this. One of the problems with cement is people will bog up, for instance, at the bottom here, and you can see a very good example. Christian's shown you how the parts of a joint have been filled, but if you look down, you'll see that the cement has been bogged up here, and now water is, because there's a crack in the cement like this and here, water is running down the panel. It's not being pushed away, it's actually running in, and you can see very clearly here the sill beam and the bottom of the joint for this upright have rotted off completely, and water has just formed compost in the bottom here. You can see here, look, if you do a bit of digging out, we've actually got the remains of timber and sill beam and so on. It's horrible, and this is all because water's been allowed to run down and pool on the joint at the bottom. Well, this is one of the sorts of things you see when you're doing surveys. Again, it comes down to drainage, but you've got a lovely downpipe going into a sort of a gully, and then it's really nothing much is happening. It seems to connect to a bit of pipe, but the pipe doesn't go anywhere. That's the end of the pipe there, and there's a hole in it. In the meantime, you've got a huge mass of masonry, a chimney, and at the very top of the chimney they've even got a tie on it. They're having to hold the chimney and stop it from falling over, and when you look at the bottom of the chimney, you can see it's sitting on some stonework, and that's it. There's no foundation at all. It's just sitting on wet, muddy clay ground. So that's why the chimney's falling over, and this was exactly how it was when I did the survey. And very good example of the sort of structural movement that you can get in a building for silly reasons like a bit of drainage.